Next we are going to see normal distribution. So introduction, normal probability distribution or normal distribution, or it is called Gaussian distribution, is one of the most important and powerful of all theoretical distribution in statistics. It is a continuous distribution. This distribution is defined by the parameters mean, mu and standard deviation sigma. A special case of normal distribution with a mean 0 and the standard deviation of 0 is called standard normal distribution, right? Or it is called Z distribution. We are going to use the notation Z instead of that, right? Normal distribution. It is a symmetrical bell-shaped representing a continuous probability distribution. If X is continuous random variable with parameters mean, mu and standard deviation sigma following a normal distribution, then the probability density function of X is defined by f of x, or sometimes we are using p of x, that is equal to 1 by root of 2 pi into sigma e power minus 1 by 2 x minus mu by sigma the whole square, right? So here the distribution is continuous, that is why probability density function, right? We are using probability. Otherwise, so we are using probability mass function, right? If it is a discrete, right? That is x lies between minus infinite to plus infinite, and mu is lies between minus infinite to plus infinite. Sigma is positive. A continuous random variable x with mean mu and variance sigma square following the normal law is denoted by x is represented by normal distribution n of the parameters mu comma sigma square. Standard normal variate. If x is a continuous random variable following a normal distribution with parameter mean mu and standard deviation sigma, then the random variable z is defined by z is equal to x minus expected value of x by sigma, that is x minus mu by sigma, is called standard normal variate. Here mean z is e of z, that is equal to e of x minus e of x by sigma, right? That is 1 by sigma e of x minus e of x, that is 0, right? That is mean is 0. And variance z is variance of z is variance of z, that is equal to variance of x minus e of x by sigma, that is 1 by sigma square variance of x plus 0, we know, right? So variance of ax is a square variance of x, that is why we are using the formula 1 by sigma square variance of x plus variance of expected value. Variance of x minus variance of x, expected value is a constant value, right? So variance of any constant is 0, that is why 0. So that is equal to 1 by sigma square. So variance of x is nothing but sigma square, we know, right? So sigma square by sigma square 1. So variance of, so the standard normal variate with mean 0 and variance 1. It is denoted by z is a normal distribution with mean 0, variance 1. The probability density function of a standard normal variate z is given by pi of z is equal to 1 by root 2 pi e power minus 1 by 2 z square, where z lies between minus infinite to plus infinite. Next, diagrammatic representation of a normal distribution. So how it will be in diagrammatically? It should be like this, right? X is equal to mu or z is equal to 0. It is symmetrical on both sides, right? So x is equal to mu minus sigma, this is z is equal to minus 1, right? And that point x is equal to mu plus sigma, z is equal to plus 1, right? Similarity, check this. Then this is inflection point, right here, this area. This is the highest point of normal curve. So x is equal to mu, z is equal to 0. So x is equal to mu minus sigma, z is equal to minus 1. Then here x is equal to mu plus sigma, z is equal to 1. Here x is equal to mu minus 2 sigma, z is equal to minus 2. Here x is equal to mu plus 2 sigma, z is equal to 2. Last, x is equal to mu minus 3 sigma, x is equal to mu plus 3 sigma, right? So z is equal to minus 3 and z is equal to plus 3. So z maximum value of z lies between minus 3, that is highest value 3, lowest value minus 3. So z lies between minus 3 to plus 3, right? So this is the lower bound, this is the upper bound. So minus 3, z is equal to minus 3 is the lower bound, z is equal to plus 3 is the upper bound, right? Next, z is equal to 0 and take z is equal to a. Here pi of a is the area under the normal curve below the z is equal to a, right? So probability of z less than or equal to a, that means z is equal to 0, z is equal to minus a. Here phi of minus a, that is equal to probability of z greater than or equal to minus a, that is the area under the normal curve above z is equal to minus a, this full side area. Above means right side, below means left side, right? Next, z is equal to b and z is equal to minus a. So area lies between z is equal to minus a and z is equal to b, that is pi of b minus pi of minus a. So probability of minus a less than or equal to z less than or equal to b. So area under normal curve between z is equal to minus a and z is equal to b. Next, z is equal to minus a. So if you are taking z is equal to minus a to z is equal to 0, pi of 0 minus pi of minus a, that is equal to probability of minus a less than or equal to z less than or equal to 0. So the area under the normal curve between z is equal to minus a and z is equal to 0. Now we are taking z is equal to a because this curve is symmetric. So what is the left side area? That is equal to the right side area. Whatever the left side, that is equal to right side, right? So pi of a minus pi of 0, that is equal to 0, probability of 0 less than or equal to z less than or equal to a. The area under the normal curve between z is equal to 0 and z is equal to a. Here both are same. Whenever we are having the negative side, area is always positive, whatever the limit. Suppose if you are taking the distance between, for example, 0 to minus 3, right, left side of the x-axis, so 3 units, right? So what is the right side, 0 to 3? That is 3 units, that is what. So whenever we are taking area, if it is symmetric, then the area is area on both sides are equal. That is what special property of the normal distribution, because it is symmetric, right? Remark, we know that pi of z is equal to 1 by root 2 pi e power minus 1 by 2 z square, that is equal to 1 by root 2 pi e power minus 1 by 2, right, minus z square, pi of minus z. Pi of z is equal to pi of minus z. Pi of the value of pi of z are same for the positive as well as negative value of z, that is what, right? Hence the standard normal property curve is symmetric about the line z is equal to 0. The area under the normal curve z is equal to minus a and z is equal to 0 is equal to the area under the normal curve z is equal to 0 and z is equal to a. Second one, remark, right, a normal distribution is characterized by two parameters, that is parameters means constant, that is one is mean mu, whose position can be located anywhere on the x-axis, and the second parameter is the standard deviation sigma, which determines the spread of its bell-shaped curve along the x-axis, right? If it is sigma is more, right, then it is a big bell shape. If it is very small, near to 0, then it is will be a small bell shaped, narrowly, right? That is what sigma decide that one, right? The graph of f of x or p of x is bell shaped curve. The top of the bell is directly above the mean mu. For the large value of sigma, the curve tends to flatten out, that is what, big. For a small value of sigma, it is sharp peak. This is for large sigma, this is for small sigma, right? Thanks.